This movie describes how to use the Function Family Challenges activities. These activities include one each for reflection, rotation, dilation, and translation. In each activity, students construct and explore members of a function family to solve challenges in which they have to match an unknown member of the family. This is one of the geometric functions activities, in which students create, manipulate, and experience function concepts by treating geometric transformations as functions with points as their variables. You can find out more about geometric functions at this URL. We'll use reflection challenges as our example of the Function Family Challenges activities. In this activity, students explore reflections as functions. They construct a reflection function, compare the motion of the variables, restrict the domain, and create multiple members of the family. Finally, they solve reflection challenges by figuring out where to put a mirror to match an existing reflection. I start the activity with a blank screen, a new sketch, constructing independent variable x and vertical mirror j. I then reflect the independent variable across the mirror and use function notation to name the resulting dependent variable, the reflection across mirror j of point x. I give my dependent variable a different color from the independent variable, and I turn on tracing. I also turn on tracing for the independent variable. Following the directions on the worksheet, I drag point x up and describe which way the dependent variable goes. Then I drag x left and again describe which way the dependent variable moves. So I investigate the relative direction and speed of motion of the two variables. I erase the traces and trace a new shape of my choice. I describe the two shapes, how they're similar and how they're different. I erase the traces again and draw a new shape that goes across the mirror. And explain what happens from dragging x across the mirror. Finally, I have an assignment to create traces that look like the ones shown here. So I need to figure out what to do with my mirror in order to make traces that look like those. So I'm going to try a horizontal mirror and see if I can make a set of traces that look pretty much like the traces that are over there. There's the traces one more time. Let's see. Go right, go down, go across, and go back up. So that's not too bad. I continue with a number of different explorations that come out of this. One of them is to create a polygon which will serve as the restricted domain for our variable. So this will be the restricted domain for the independent variable. I select both the independent variable and the domain and merge the point to the pentagon, and then erase my traces and animate the point around the restricted domain. And I get to see what shape the dependent variable traces out as I trace out the restricted domain with the independent variable. The last question I have to answer in this particular activity is to compare the range in blue to the domain in red. What features are similar? What features are different? How do the features relate to the relative motions? And are these shapes congruent or similar? Finally, students explore a number of challenges designed to deepen their understanding of the reflection function. Here's the first. The challenge is to match the reflection shown here from the blue polygon to the green polygon. So mark AB as the mirror and reflect the independent variable across the mirror, naming the independent variable appropriately. We always emphasize proper use of function notation. And we need to figure out where this mirror should go so that if I trace the given domain with the independent variable, the dependent variable will trace out the green polygon. So I'll experiment a little bit. Let's see. Let me get this over somewhere closer to the green polygon. Okay. Now I'm at this tip. I ought to be at that tip over there on the green polygon. So I'm going to adjust. Oh, that's not too bad. Wonder if I have it now. Oh, I've got it pretty doggone close. Okay, a little bit of fine tuning and I'll be all done. So, by constructing and investigating all four fundamental families in this way, students will gain a strong understanding of function notation, of the relative rate of change, the covariation of the variables that characterize each function. They'll restrict the domain and use the restricted domain to investigate the correspondence between the range and the domain, and whether they're congruent or similar. And finally, students will solve interesting challenges that involve finding an unknown member of each of the families that they investigate.